So this is an applied science meeting, so we're going to collect a little bit of data. So how many of you here, this is show of hands, are in the Smith River watershed for the first time? Okay. Way cool. Welcome to the Smith. How many of you have been in here but mostly on the river and not really up in the watershed? A few people. And then how many here are familiar with the river and its watershed? Yeah. Okay, so we have a kind of a broad range of expertise here. And so once upon a time, there was a young man who was just trying to figure out which way was up. And he accepted a job on one of the 600 ranger districts on one of the 158 national forests in the National Forest System. And that was the Gasky Ranger District, which would come to be later on the Smith River National Recreation Area. And that person was me. And I took the job without ever having been here or seen it. I just looked at the map and it was close to salt water, and that was enough for me. And so I arrived here and they told me all the responsibilities that I would have, and I was just bewildered. It's 350,000 acres, there were hundreds of miles of road, but I did look around and went, wow, look at this place, look at this river, look at this amazing watershed, and I felt really lucky. And I felt sort of the weight of having to speak for the soil and water resources in such an amazing place, in a place that was clearly world-class, absolutely world-class. And there was lots of action back then. The Forest Service was still in very much of an extractive mode. There was a lot of clear cut, burn and plant. Or it was called colloquially whack 'em, stack 'em, and black 'em. And there was a lot of that happened here. And a little bit later, there was a huge surface mining proposal in the North Fork. If some of you may remember the California Nickel Project. Yeah, and it was the expectations of having to apply science and describe what the impacts would be, predict the impacts, and try and protect soil and water resources in this amazing place were really weighing on me. And I found the place to be bewildering. All sorts of diversity and all sorts of different processes going on. And I was looking for a way to organize my observations and organize what I could learn about the place as I went. And I basically hit upon this idea that you start with the bedrock, you start with the geology, and boy, did it ever work. It really, really worked for me. And I'd like to sort of go in and give you a little bit of a sampling of how that works. And you know, you have to spend a lot of time in a place like this to kind of get to know it, but really you don't know it. You know yourself better, and the place has helped with that, as they say. And so I don't claim to know it, but I did spend quite a bit of time here. I was a district hydrologist for a little over 10 years, and I've been coming up here ever since. As soon as I retired, I had always been in awe of the Smith River Alliance and joined the board, and still am involved in the Smith River. So I'd like to give you a little bit of orientation to the place. I think you know what this is, and this is our wonderful watershed right here. And then if you're a tectonics nerd, or you know, everybody knows what plate tectonics is now, but here we are right here. This is the famous Mendocino Triple Junction. This is that Cascadia subduction zone that will treat us to a monstrous earthquake anytime now, maybe tonight, who knows, you know. And this is how it looks in cross section. We're riding over the top of this Gorda plate. This is the coastline here, and this is the top of the watershed. So we're riding on top of that plate. And then here's the watershed. Basically, it's 724 square miles, and that's a big place. However, it's the Klamath watershed is 21 times larger, and the Trinity is 4 times larger. but I would submit that this place, being even kind of on the small side as rivers go, is just right up there as a really primo place. And it's about 28 miles wide, so it's fairly short, coastal watershed. And this is the topographic setting. We're around in here somewhere, and you can see the green is the lower elevations, and it gets to brown at the higher elevations. It basically goes from sea level to about 6,410 feet at Bear Mountain. And then this is the high elevation country of Ship Mountain and Bear Basin Butte and that. And then the North Fork has some high elevation as well. And it's the same up in the Red Mountain area. And then I'm going to draw some distinctions for you, but one of the big ones is there's geomorphic provinces or geologic provinces in California, and the Smith River covers two of them. So it is a piece of the Coast Range in the lower river and the Klamath Mountains province in the upper river, and the Coast Range thrust fault that goes through here. And this is very significant when you're trying to draw distinctions and make observations about the place. And I'll fluff that out a little bit more for you. And then here's a look at it if you were a very high-flying bird coming in from the ocean. And here's the geologic map. And I'll try and explain this to you a little bit, but basically I'm going to generalize things and simplify them. And if you're a geologic nerd, you're going to be thinking, now wait a minute, that's not always true. And you forgot about this. And you know, I'm trying to generalize it and simplify it. It's like physics. The physics they teach you in Physics 101 is all wrong, but it's useful to simplify it. So I'm doing that. And then I would also like to acknowledge some of the geologists that I have collaborated with: Thomas Dunklin, Rocco Fiore, David Rhodes, Bill Long, and especially Dylan Caldwell, who's also on our board. And I just read his wonderful thesis and have contributed to my further understanding of how geology is destiny in the Smith River. So we'll shine the geology underneath the watershed here, and I'll start going through some dichotomies for you that will help you in a simple way to understand this place. So first of all, we have the Klamath Mountains province, as I mentioned before, and the Coast Range province. So the green here is the Coast Range. The Coast Range thrust fault goes right through Hyuchi, probably goes right under Grant and Patty's house. It's actually it's a wide zone, but it goes through Hyuchi, and that's kind of the break there. And then the rest of it is the Klamath Mountains province. And basically you can think of it as the upper river and the lower river. And they're really quite different in a bunch of ways. First of all, the upper river is public land by and large. Almost all of it is public land. And those areas where people don't live that are still private land is a major focus for the Smith River Alliance to get those areas into public land and into a conservation framework. And the lower river is private, by and large. And as Marissa mentioned, this has now quite a good solid conservation framework of the Smith River National Recreation Area and a number of wilderness areas, and sort of a modern social acceptable management of public land, whereas the private land, some of it may be well managed, some of it maybe not so much, but it is all sort of subject to development and not really in a conservation framework. The rocks and soils and everything are older as you go from east, old, getting younger, younger, much younger, very much younger. So there's a east to west, old to young. And that's significant in a number of ways. These rocks are harder and less fractured and less landslidey. These rocks are softer and more erodible. And then these are just coastal sediments for the most part. And so this area has clearer water, and I'll talk about why that water is so clear at the end of the talk. And this has kind of muddier water. And this is a little bit more like Eureka area or the rest of the north coast where the streams run kind of muddy, and this has the very clear water that Smith is so famous for. This area is forested and steep, and this area, the lower river, is not forested and quite gentle. And the channels in this area are steep and full of bedrock and boulders, and the channels in this area are gentle and gravelly channels, and just not as steep, often even sandy channels. This area tends to have very high low flows. So the amount of flow in the summertime is much higher in these upper river and in this Klamath type geologies than it is in the lower river, by a lot. And it's probably one of the reasons that the Smith is so productive for fish, is that we have a lot of water in the summertime. And you'll notice that tomorrow if you go swimming, it's still pretty cold and there's a lot of water down there. And it's not that big a watershed, but it yields a lot of water in the low flow period. And then there's sort of intermediate and low fertility in this area, kind of shallow rocky soils, and high fertility in this area, kind of deep and productive soils. And so I'm going to go through the, and you can break it up basically into three forks. Of course, the North Fork, the Middle Fork, and the South Fork. And I'm going to describe each of those in terms of some of their characteristics related to the bedrock. I'm going to go back to this slide to do that. So first of all, I'll talk about the estuary, because even though it's in the lower river, it's a special area. It's the saltwater freshwater interface, and it's really a keystone area for fish. It's absolutely essential for fish, and we're just really starting to appreciate that now. You need to do everything to protect and restore habitat, but if you don't do the estuary, you're really not going to have salmonids of any consequence. And one of the reasons the Smith is still in okay shape, it's not where we want it to be, in okay shape, is the estuary is not as mucked up as most of the rest of the estuaries in the western US. Most of the estuaries in the western US are completely gorked by diking and draining. And we're starting to fix that. And we didn't know we were doing that, but we really ruined the estuaries almost everywhere. And there's a lot of work to be done here, as Marissa has pointed out. So it's not where we want it to be, but it isn't wrecked like most of the estuaries are. And so we're starting, not at the bottom where we might be in Humble Bay. We're starting up here, and we want to get to up here.
How does it compare to the Eel River estuary?
That's kind of a complex area, but answer. They're very different estuaries, but I can't. In terms of fish production, I'm out of my pay grade here, out of my expertise, and so I don't really want to answer that. But we could explore that. Yeah.
Compared to the road, it's pristine.
Yeah.
Well, they're similar, and there's a lot of agricultural use in the eel. We haven't rip-wrapped everything like we have in some of the other.
Yeah, there are some dikes, but basically the river is entrenched in the lower end, and the diking wasn't really going to buy much in the lower river. And so there's problems with riparian vegetation and culverts and reed canary grass and on and on and on, but we don't have a bunch of dikes that we need to take out. Whereas in most places, that is the problem, is the dikes are restricting the size of the estuary. Redwood Creek is a great example. That all of the work that's been done there, they can't really get the fish back because the estuary isn't fixed. And they aren't able to fix it because it's private and they don't have a willing landowner yet. So eventually, but the other thing about the estuary is that's where sea level changes. And sea level controls the whole river. This river feels the sea level, even way up here. And sea level changes from the glacial interglacial periods about 460 feet. And so only 18,000 years ago, which is nothing geologically, the coast was another 6 miles out from where it is now, because the sea level was, basically 120, 140 meters lower than it is now. So that really makes a big difference. And Dylan Caldwell has shown that the sea level actually affects how the river evolves over time. And really, the sea level is usually changing quite quickly in Earth's history, but we've had this weird 6,000 year period where sea level has been stable. That's over now. The sea level is rising. It ought to be falling, but it's rising because of climate warming. But that 6,000 year period created a lot of stability in the entire system. And it's kind of as good as it gets with a high stand of sea level and a stable sea level. That's not usually what the Earth does. So, and then looking at the coastal plain, it's the coastal plain here, and Lake Earl and Crescent City and that are not strictly in the Smith River watershed. They don't drain into the Smith River, but they're really in the orbit of the Smith River and are considered by many to be part of the Smith River Basin. And this is basically young and not so young marine sediments. Some of it's really quite young, and these near coastal features are all basically 6,000 years old. They developed during that period of stable sea level, which is true worldwide. And basically this is uplifted marine terraces. So this used to be ocean bottom with lots of sediments on it. It got uplifted, more sediments from the river and whatnot. And it's quite fertile. It's used mostly for agriculture and residential areas. And so moving to the North Fork, oh my God, the North Fork. This is a really interesting area for geologists and botanists and miners and lots of people. It's a fascinating and weird place. And it largely consists of this purple is ophiolite. And it's mapped as peridotite. So ophiolite is something that develops on the ocean floor when this particular tectonic setting happens. And it's actually a parfait of several different kinds of rock with peridotite at the bottom. Well, all that other stuff is gone now, and what's left is the peridotite and serpentinite. It's often called serpentine, but it's really, peridotite is the correct term, and it has various degrees of serpentinization. And there's bodies of these ophiolites all over the world, but this is the largest one in the world. It's called the Josephine Ophelite. It's 1,200 square miles, and it's by far the biggest ophiolite body in the world. And this rock should normally be on the ocean floor. It's very heavy rock, and by tectonic happenstance, it happened to be thrust up and became the North Fork of the Smith, and actually a lot of the rest of the Smith is this same kind of rock. And it's very heavy. It's full of metals. It's the heaviest type of rock that you will find on Earth, and that's why it's normally at the bottom of the ocean, not up on the continent where the rocks tend to be lighter, but it happens here to be up on the continent. And
that's basically the oceanic crust sticking up to the continental crust.
That's right.
Under the ocean.
And basically it has very weird soils. And you know, I can't say enough about magnesium.
Tell us about magnesium.
It helps you sleep. It's good for you. I take it. And I'll have some bottles for sale afterwards.
Can you tell us about zinc also?
Yeah, that's right. But it also is rich in a bunch of other metals, including zinc and nickel, chromium, cobalt, copper, and a bunch of others. So it's a heavy metal type of a rock. And the soils are really strangely infertile. So when you go look at the North Fork, it looks like a desert, even though it rains 120 inches a year. It's like, what is going on here? And basically the problem is there's way more magnesium than there is calcium. The magnesium is not toxic to plants, but they don't like a lot more magnesium than there is calcium. So most soils are like 10 times as much calcium as magnesium. Here it's just flipped. There might be 10 times as much magnesium as calcium, and it just doesn't work for plants very well, and they have a hard time adapting to it. There are a bunch of plants that are specifically adapted to it, and other ones that kind of tolerate it, but they don't grow very well, and they're quite unusual. The botanists just love this because there's a lot of endemism of a number of plants that only grow on this kind of material. An important thing about it, though, is that because of all the iron in the soil, it is incredibly resistant to erosion. It just doesn't erode unless it rains super hard. If you have an incredible downpour, the North Fork will turn red for a couple of hours, and then it turns green again. It's kind of amazing, but basically it's insanely resistant to erosion. And on the flatter areas, the areas that are interesting to miners, the soils are like 30 to 60 feet deep. They're million-year-old, very, very deep soils. And that's because they're so erosion resistant, and on the flat areas, they develop very, very deeply. And then over time, as they sit there and develop, they concentrate those metals. And this is what the miners have been interested in, is the metals that are concentrated in that soil. So in a lot of mining, the soil is in the way. They have to scrape it away to get to the rock. In this case, the ore is actually the soil itself. And most of the nickel in the world comes from deposits that are just like this. And fortunately, we get plenty of nickel from places like Cuba and Zaire, and we don't need to get it from here.
Is there still an active application then to mine nickel up there? There's a Canadian company.
It's not really an application. It's a claim and a bunch of noise that's being made, and it's a major focus of the Smith River Alliance to make sure that that never happens. Is anybody in favor of mining in the North Fork of the Smith? Yeah? Show of hands. All opposed? Okay. We're going to try to make that happen. Most of the mining threat is gone with the establishment of the National Recreation Area, and the existing claims have been abandoned, and they can't be relocated. So there's a big story there that I don't have time to go into, but it is one of the threats that we're dealing with here, is a mining proposal on Baldface Creek. And the Smith River Alliance and a number of other groups are all over it, and we are determined to not let that happen. And so the Franciscan Formation, this area here, is kind of transitional between the upper and the lower river, and it's Hyuchi, and it's also one of the crown jewel tributaries, Mill Creek, which has softer, younger rocks. It has gentler streams. It has this gravelly substrate, a lot of slow water, and it is something that is coho heaven. And that's really the center of coho production in the Smith River, is Mill Creek. And of course, it also has redwoods. This is where most of the redwoods are, is in Mill Creek. And on that Franciscan Formation, those fertile soils on that soft, fractured rock. And then the South Fork, so where are we? Is this, this is Rock Creek here, so we're up in here? Yep. Yeah, so when you drive in, on your right, or to the west, is that peridotite, is that serpentinized peridotite. And it's really jumbled up. And then on the other side of the river, generally, is more the Gliese Formation, marine metasediments over here. This is a major geologic unit in the Smith, what they call the Gliese metasediments. And this Rattlesnake Mountain, this peridotite that's along the South Fork, is nothing but nested landslides, ancient landslides with a few fresh ones, like you will see just downstream here, or the Rattlesnake Slide. It's a real jumble. And so when you have flatter lands, you develop deep soil, but when it gets steep and when it's been pushed up, by tectonic forces, it can really erode like crazy. And you'll see that when you drive the road and say, this road is high maintenance, to say the least. And the upper South Fork is different. There's a combination of the peridotites, but also diorites like you find in the High Sierra or in the Trinity Alps. and they have a very different vegetation, different soils, different stream types. There's a little dike of siltstone in here, and it's actually quite an erodible and landslidey place. If you look at the photos, that's where a lot of the streamside landslides are on the river. And it's a different sort of place, and the upper middle fork is kind of similar to that, and that's where we have the highest elevations. It's very steep, and then on the granitic or granodiorites and diorites and gabbro, the soils are quite productive, and there's some really beautiful stands of forest up there. And then if you go up there, when you go from the peridotites to the diorites, there's tremendous contrast. It's really like night and day, and like, oh wow, something changed here. If you really want to see that, you go along the Clear Creek Trail over on the Klamath side, where it goes between granitics and serpentinized peridotite, and the contrast is just stunning, and that's where you'll really see geology as destiny. And then the Middle Fork is a complex place. It kind of goes between the Gliese Formation and the peridotites, and then there's some kind of jumbled up areas here. Patrick Creek has a lot of faulting and a lot of complex geology, and you can see that in the stream channel and in the landsliding, and then it's quite steep up here. And the Middle Fork is kind of dominated by the highway, unfortunately, which is an irreversible impact that we have to live with. I'll leave it at that. The Middle Fork is a somewhat more complex story than the other forks. And so one of the things that the Smith is really known for is the color. You know, it's what people really notice. Even when they drive by drive over the bridge, they go, wow, look at the color of that river. And so do you know why that is? Anybody want to venture?
Must be the geology.
Must be the geology. It has something to do with the geology. So it's magnesium. Of course, it's magnesium. So most people think it has to do with the color of the rocks, and you're seeing the rocks underneath the water, and that's not the case. It might have a little bit of an effect, but if you look at the river, the rocks are gray or brownish gray, and they don't really look different than other rivers. So that's not the factor. And basically, it's a property of water that's clear. It's a basic property of water, not a property of the river, but it's combined with the property of the river that yields really clear water. And you see that kind of color. And the way that works is water will absorb or scatter red first, and then green, and then blue. So when you see really deep water, when the ocean is really clear, it's just blue. There's no green, there's no red in it. And then it gets shallower and shallower, and there's more green in it. And if you get a certain kind of intermediate depth, you get this beautiful turquoise, the Caribbean blue, really. And then when it's really shallow, you don't have that color. Or when it's full of mud or algae or something, you start to see the reds and there's a brown color to it. So that's basically a property of water, a wonderful property of water, and a property of the river that yields really, really clear water. And so to finish this quick description of the place, I'll try to explain to you why the water is so clear and why this happens the way it does. And like almost everything in our business, it's not one thing. And it's not the magnesium, unfortunately, but it's a combination of things. And this is my guess from all these observations and all this time I've spent up here as to why that water is so clear. It's not because nothing ever got done here. The Forest Service had its way with this place for a long time. And this was actually a timber basket for the Six Rivers National Forest. It cut a lot of timber out of this place and took out a lot of primary forest, which is, you know, no longer socially acceptable. It's no longer even permitted in Vietnam or India or Taiwan and a number of other countries. It's still allowed here, but it's not really socially acceptable to cut old growth or primary forest so much anymore. And I would submit that we ought to evolve to the point where primary forest is off limits. Or the world term is not old growth, it's primary forest. And it ought to be off limits in my view. But basically you have hard rocks. And the whole upper watershed. Oh, I should mention the fact that the Gasky Ranger District, I arrived here and went, wow, this is a watershed district. The whole upper watershed is this ranger district, along with the Chetco Ranger District on the Siskiyou National Forest, or what's called the Rogue Siskiyou now. So the whole upper watershed is public land. It's really amazing, and that's not true of most national forests. I've been all over the place, and most of them are not like that. And so that's an amazing thing. It's national forest land. It's not Forest Service land. Forest Service doesn't own any land. Please don't call it, don't say Forest Service land. Forest Service is the manager. It's national forest land. It's your land. And of course, Mill Creek belongs to the state parks. It actually belongs to you if you live in California. So basically hard rocks, highly resistant soils. These peridotite soils are especially resistant and yield an amazing clarity of water. So the least sediment yield, the most clear water is from the North Fork. It's because of those peridotites and because of the iron oxide, and the magnesium probably has a little bit of something to do with it. And earth flows are nearly absent. So the big earth flows that continually feed mud, say, into the Mad River or the Eel River, you don't have those here. And the stream banks are basically rock and boulders and are just bomber. And you don't have stream bank erosion that happens on so many other rivers. And there's an argument that the forest practices have been, recent forest practices have been relatively good. So there's no tractor logging, Richard. There has been no tractor logging for the most part. And after a few years of really disastrous road construction, where all the roads washed out, they brought in a bunch of geologists and geotechnical engineers. They said you have to put the roads on the ridge tops, you have to do geotechnical evaluation of the locations, they're outsloped, they're heavily rocked. You don't have a lot of yield from the road systems. The county roads are another story, but anyway, you have better forest practices. There's a number of other factors that are minor, but one other factor is that there's not a lot of algae in the system. The upper river is relatively nutrient poor and has high low flows. And some of the waters that come off are actually sort of algal toxic. And toxic's not the right word, but they inhibit algae growth because of too much magnesium. And this isn't well studied, but toxicity from copper, sometimes lead, and other metals that actually inhibit algae growth, which would make the water less clear. So those are the kind of the combination of things. Another thing is that there's very abundant vegetation in the areas that aren't peridotite and naturally resistant. There's very, very dense vegetation. This place has many, many levels of understory. It's an absolute jungle. If you've ever tried to walk around through a lot of this lower elevation stuff, it's a total jungle. And then when it does, when it was cut over, or when there's a big disturbance, it revegetates very quickly because of the high rainfall. And so basically that's a little bit of a sampling of how I organized my observations and predictions about this place, and why I believe that is destiny. Yeah. So just to close the evening, you know, it's kind of cliche to start with thank you, so I want to end with thank yous. And particularly for the Smith River Alliance, who is hosting us here in this amazing place where we can gather. And the Salmonid Restoration, which has just been this amazing institution. The first talk I ever gave in my whole career was at SRF conference, you know. And
The one where you made us sing like Kumbaya.
no, that was the second one or something. And so,
Yeah.
talk about alchemy. This is how you change magnesium into calcium. You get two groups like this together, and it's just magic. So let's end. You know when a soccer player makes a goal? A goal.
Taking shirts off?
No, what do they do?
They're running.
They do this at yes. Okay, so let's do that in honor of the Smith River, the Smith River Alliance, and the Salmonid Restoration Federation. 1, 2, 3. Yes! All right. Thank you very much. All right.
Mike, we heard there could be questions. Curious,
Questions?
how much part does silica play, or does it play much of a role in the Smith River? Silica.
Yeah, silica is actually quite low in the peridotites. There's plenty of it, but there's a lot more iron relative to silica, and then the silica is leached out and concentrates those metals. But silica is one of the most common elements on the earth, and so there's plenty of silica around, and it's pretty inert, actually. Yeah, plants don't eat it. We just make transistors out of it. So,
I've got a water question. Does the geology have something to do with why there's so much water in the summertime?
Yeah.
yes, I'm sorry, I was going to mention that. There's USGS has worked out a comparison between the Mad River and the Smith River for the 7-day, 10-year low flow. So how low it can get. And the Smith River is almost 10 times as high as the Mad River per unit of drainage area. And has something, we don't really know. It's so deep you can't study it. But the basement rock here holds a ton of water. And it yields that water in the summertime. And it remembers the heavy, heavy rain.
How many years, like, is some of the water coming out 5 years old or 10 years old? I mean,
Yes, the water is...
all the water comes out the same year it falls, it drains out of the watershed into the ocean. But here,
Right.
longer residence time?
Yes, years.
Years.
And when it rains hard, the flood that comes in the river is largely water that's been pushed out of the ground hydraulically by the water that's coming on top. It's not the rainfall, it's the pushing out the older water. It's a complex picture, but mainly it's old water that you see. And the water that's in the river now has probably been in the watershed for a few years at least.
Wow.
Yeah.
Mike, is it
yeah.
fair to say that it's because the rocks are so highly fractured that there's so much water held in them and released slowly?
It has to do with fracturing for sure. But what those patterns of fracturing are and why the basement rock holds so much water is not known. Yeah, but we can see it in the low flows. It's like, look at all this water.
Well, and if you go around and look at hillsides, there's water seeping out of hillsides in August.
That's right, yeah, yeah,
In
yeah,
August.
yeah,
Just flow of water.
yep.
Mike, there's above Indian Bar on the South Fork, there is some kind of vein of clay, really fine clay, that keeps dumping in during all kinds of times, but usually after a little bit of rain. I'm just wondering if you're familiar with it, because it just clouds up the South Fork. I've seen it look like milk, but this has been going on for 6 or 8 years now.
No, I'd like to take a look at that. And we were just talking about Indian Bar in the board meeting, and
It's one of the exceptions that he was talking about in his
Yeah.
introduction. You know, it doesn't fit into the generalization, but it's above Black Hawk Bar. And
Okay,
it
yeah.
definitely colors it up at the times that you're talking
Yeah, it doesn't take much mud to color up the river.
It's amazing.
Yeah, and then if you have a landslide or a particularly bad road, you can color up the river like crazy. Like French Hill Road was badly muddied up by a few bad drainages on the county road for years. You know, so there's a lot of nuance and kind of fine scale events that you'll notice when you go kicking around.
Can you point out those locations on the map that you guys were just talking about?
Indian
Indian Bar.
Upstream of Rock Creek.
Let's see.
It's
So
like right here.
right there.
It's this is Jones Creek. It's like up here.
Right.
Yeah.
Big flat. That's Goose Creek right there.
This is Hurdy-Gurdy,
This is
Jones, Goose
Hurdy-Gurdy,
Creek,
Jones, and then
Indian
that.
Bar's up here. Yeah.
It's right there.
One of those sedimentary inclusions that may be weeping out of there.
Yeah, it may have. I mean, this is a kind of a weepy place too. This has high sediment yield because it's this weird siltstone sill in there, and it may be something that just recently got exposed.
Yeah, you can see it on Google Earth. If you just
Uh-huh.
go to Google Earth and you can look at it. There's a lot of water running through it.
Endless surprises. Yeah.
I heard there were rumors of limestone caves in the upper watershed.
You know, that was in my notes, and I forgot that. Yes, there's a lost caves of the Siskiyous,
Yes.
and we're sure they exist, and nobody knows where they are anymore. The people that found them wouldn't tell, and they've faded into obscurity. And go look for them because they're probably pretty extensive. And
That found
It's
them
a
told
Bigfoot
the
travel
Forest
way.
Service,
they told the Forest Service that they found them, but the Forest Service wouldn't promise to protect them, and so they wouldn't tell them where they were. Yeah.
So even
And then
with this delightful, colorful map, there's no indication about where you would guess it might.
no, the scale, it's hard to see. I've looked for them, and there's been all sorts of efforts. I think if we fly, Thomas and I are going to go up there and fly drones around and see if we can find them. Yeah. But what I did find is that the South Siskiyou Fork has quite a bit of limestone in it, and the Siskiyou Fork proper has none. And so that's a clue that it's in the South Siskiyou Fork. So go forth and find the lost caves of the Siskiyous. And there's even a rumor that they're connected to Oregon caves. Wouldn't that be cool?
Right.
I've always heard we have a high level of asbestos in the dust on the roads up in the mountains. Does that play any factor in the river at all? Is it a concern?
Probably not in the river. You know, ingesting asbestos is not anything like breathing it. And there is asbestos in certain types of serpentinized peridotite. And if you're up in the North Fork in that kind of material, try not to breathe the dust. It would be a good idea not to breathe the dust. And sometimes you'll find a soapstone, you know, that real white, soft stuff. That's almost totally asbestos. Yeah. So lovely. Yeah. Oh, look at this. Yeah. So that it's the North Fork is got some nastiness about it. It occasionally exceeds the EPA freshwater limit, 24-hour limit for lead, which is no problem for us. The fish are much more sensitive to metals in the water than we are, but it's just an indication of how metal rich that place is. So,
Mike, you dispelled the idea that serpentine is causing the color of the river to be green and all that. Which
Yeah.
is great. But one of my questions is the steepness of this green topography. Does that have anything to do with the light refraction and the color of the river when you've got these steep mountains, you know, covered with green trees?
yeah, so there'd be some reflection of the green forest. So there's a bunch of stuff. Yeah, so that's a good point, Joe. That reflection of the green.
I'm curious. I mean,
Yeah, but it's mostly river clarity. So you know that picture that I posted on Facebook of it was the pool right under the slant bridge that's what 60 feet deep. You know, it has this amazing color, and that's, you know, there's just rock on the other side of that. So it's basically water clarity, and you would get that same color in any river that was that clear. And actually, the Salmon River sometimes looks that way, and other kinds of places look that way. So, you know, we can't claim that as this is the only place that has that color. It's not really true. Blue Creek. Why do they call it Blue Creek, I wonder?
Right.
Yeah.
It's even clearer.
Yeah, it's even clear. Yeah, it's out of the watershed, but the Gasky Ranger District has the Crescent City Fork of Blue Creek. It's the only part of the Gasky Ranger District that isn't in the Smith watershed.
Creek is not as deep.
Still.
Yeah.
But it's still,
But you get an intermediate depth, and you get the greens and the blues, and you get that turquoise that is out of this world. Yeah, and you don't have to go to the Caribbean to see that Caribbean blue. So, okay, any more?
Yes. I have a favorite word that I've first heard uttered by you when talking about the geology and soils of this area. It relates to the minerals, right? Lots of magnesium and other metals in the soil. Is the mineral word I'm talking about ultramafic?
Ultramafic, that's right.
Is there a reason you didn't say that, since we're speaking superlatives here?
Well, I'm glad you mentioned it because it's an important word, and it does describe these rocks. They're ultramafic rocks, and there's a bunch of different ones. There's
What does mafic mean?
yeah, and I can't say enough about magnesium, really, but no, but it's these heavy metal-rich rocks.
So it's a valid word still.
It's totally a valid word. Yeah. And you can even use it as a password if you want. You know, nobody will ever guess that one. So.
How about the well-hung lags of the North Fork? You want to talk about those a little bit?
Even on the south.
Yeah.
You mean the conglomerate?
Yeah.
Yeah. And so those are probably magnesium concretions. Magnesium. In a lot of places you say that's calcium carbonate. In the North Fork it's magnesium carbonate. And that was verified by Bud Burke when we were rafting with him. So, yeah. The North Fork's also very nitrogen poor. And that's why you have Darlingtonia in these peridotites. And, yeah. And another reason the vegetation doesn't grow very well. So. All right.
Thank you.